Hello viewers, this lecture is about IP addressing. It is listed under 1.2.2 in AS syllabus. It requires you to explain the format of an IP address and how an IP address is associated with a device on a network. Secondly, explain the difference between a public IP address and private IP address and the implication for the security. Thirdly, explain how a uniform resource locator is used to locate a resource on the World Wide Web and the role of domain name servers. So let us start with the IP part of IP address. The IP part of IP address stands for Internet Protocol. The address part refers to a unique number that gets linked to all online activity you do. Somewhat like a written address on a letter you would send out. All this happens in milliseconds. So there we go. Nowadays, we are all on internet, and it seems that we are always connected through our personal computers, laptops, or mobile phones, or mobile devices. And every time you go on internet, an IP address is right there working for you. And with so much obscure information and let's say misinformation out there about the IP addresses, it's helpful to know the basics. Let's just discuss basics first. You have got connections with internet. Your computer is hooked up to the internet one way or the other when you go online for email or um, to stop to shop or to chat. Your request has to be sent out to the right destination. And the responses and information you want need to come back directly to you. So IP address helps there. And IP address plays a significant role in that. So you and your computer actually connect to the internet indirectly. You first connect to a network that is connected to the internet itself and grants you or gives you access to the internet. Uh, that network might be your internet service provider at home or a company network at work or a wireless network at school or cell phone when you are on the road. But with the millions of computers on the internet, how can your single computer or cell phone jump right in and get you work or personal emails and more without any problems? So it's about protocols. To make sure you can do your thing on the internet, your computer's network software is hardwired in it to follow a list of built-in networking standards and rules called protocols. To connect to internet and to swap information and data back and forth. Okay, one of these networking protocols on your computer, the Internet Protocol or IP, is responsible for addressing, delivering, and routing your online requests precisely. It attaches an electronic return address to all your online requests and activity for you. So IP is actually very necessary. This address is um, uses um, the computer that uses this address needs it until or unless a computer or whatever the device uh, that we are actually using does not have this address, IP address, it would not work. So IP address, it was nice while it was lasted because it does not go with you all the times. When you are at home, an IP address is assigned to your computer by your internet service provider, like PTCL that we have, since they are the ones giving you access to the internet. It's their role to assign an IP address to your computer, your cell phone. Your internet activity goes through them and they route it back to you using your IP address, which they assigned earlier. But don't get attached to it because it's not really yours. Even at home, it can change if you do something as simple as turn your router, the router that is given by PTCL or your service provider, on and off. Or you can contact your internet service provider and they change it for you. You cannot take it with you, never. So if you go on vacations and take along your laptop, your home address, IP address does not go with you. It cannot, because on vacation you will be using another network to connect to the internet. So when you are at a coffee shop, let's say in another city or maybe just down the road, and you are using the Wi-Fi to get your email, in that case, uh, you are using different IP address and it is temporary as well. One assigned to your laptop or your cell phone on the fly by the ISP for that coffee shop's internet service provider. Same thing happens when you travel. Uh, when you travel, as you move from airport to your hotel or to a relative to the local coffee house, or to the local coffee house or maybe hotel, your IP address will change each and every time, but you don't have to think about it at all or open your computer to find it out. It all happens thanks to the intelligent design behind the internet, wireless networks, and all those internet protocols your computer uses. So in A2, we will discuss about further protocols. Over here, it's just a matter of your IPs that we are going to discuss further. So, uh, so until now, you would have knowledge that the internet is based on TCP/IP protocol. Protocols define the rules that must be agreed by senders and receivers on the internet, and it is done by TCP/IP itself. Every device over the internet follows it. Protocols can be divided into TCP/IP layers. This is part of A2 and IP, Internet Protocol. So Internet Protocol has got two types of addressing with it. First is called IP version 4, IPv4 addressing. IPv4, IP version 4 addressing. The most common type of addressing on the internet. IP version 4 or IPv4. This is based on 32 bits, based on 32 bits, which becomes 4 GB almost, 4294967 296 possible addresses. The 32-bit these 32 bits are split into four groups of 8 bits, thus giving a range from 0 to um, um, 255. For example, we have 8 bits, 1 byte here, then a dot, then a byte, then a dot, then a byte, then a dot, and then a byte. And 1 byte can accommodate from, we know that from 0 to 255, from 0 to 255. So let's say an example would be 254 dot 0.128.77. This is a legitimate IP address. So the system uses a group of these group of bits to define network ID, net ID, and network host, host ID. The net ID allows for initial transmission to be routed according to the net ID, and then host ID is looked at by the receiving network. Networks are split into 5 different classes. So let's discuss those classes, network classes. So we have class A, whose IP range is from 0.0.0.0 to 127.255.255.255. And then um, this type of network is very large. And then we have class B that has 128.0.0.0 to 191.255.255.255, and it is medium size. Then we have class C, which is 192.0.0.0, and this belongs to our home networks and office networks mostly. So this is 223.255.255.255, and it is actually small network. And then we have class D, which is actually starting from 224.0.0.0 till 239.255.255.255, and it is used in multicast networks. And then we have E class, which is experimental mostly, 240.0.0.02, 255.255.255.255. It consumes whole byte. It is actually experimental. Now consider the class C, and in class C, we have an IP address 190.15.255. No, let's make it 25.240. And let's convert it to be in binary form. If we convert it to binary form, it would be 190 dot 15 dot 25 dot 240. All right, so it can be seen this way as well. Computer understands it, since we know that computer can understand binary numbers easily. And um, it can be seen this way in class C. Any IP address can be converted to its binary form and can be accessed through computer directly. The problem with this IP network is it soon becomes clear that this IP version 4 system provides insufficient addresses range. Nowadays, we have got computers, laptops, even IoT devices. Everyone is connected to, everything is connected to computers nowadays. Even I have heard that these processors that we have nowadays having their own IPs and all. For example, a user with a medium-sized network, which is class B, might have 284 host machines at office, and their class B license allow them to 2 to power 16, that is 65,536. This means several of the allocated IDs will not be used, which is a wasteful thing. So there is one thing called CIDR, classes interdomain routing, that is used to deal with this issue, but that's not our part of A level, so just ignore it. Like IP version 4, we have got another extension to it, because IP version 4 is actually having less number of IPs now available, since there are so many devices that which are attaching nowadays to internet. This doesn't fulfill the requirement of having these unique IPs. So for this reason, they have made another IP addressing system, which is called IP version 6. IP version 6 addressing. Let's discuss this IP version 6 addressing. IP version 6 has been developed to overcome some of the problems associated with IP version 4. The system uses 128-bit addressing, which allows for much more complex addressing structure. An IP version 6 address is broken into 16-bit chunks, and because of this, it adopts to the hexadecimal notation. So let's see, it is um, um, A. Let's have one example IP address in IP version 4 thing. It is ABFB, ABFB 7A B B, then F F F 0 and 0 F F F, and then 3D to 1. It's long address always. 2085 and 66 FB F0 FA. So one hexadecimal digit takes 4 bits. So these two are 1. So 1 byte, 2 byte, 3 bytes, 4 bytes, 5 bytes, 6 bytes, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So one IP address takes 16 bytes because it is 128 bits. Note how a colon rather than a decimal point is used over here. In IP version 4, we used a decimal point. Over here, we are using colons. It is designed to allow internet to grow in terms of number of hosts and the potential amount of data traffic which is nowadays being flown. IP version 6 has benefits over IP version 4. Uh, it has no need of network address translation. Network address translation is when we are using home networks like with routers from PTCL or any ISP. Uh, we actually, that ISP gives our router or a home just one IP address, whereas inside our home, every device has got one local IP address. So these local IP address, when they contact with the router so that they could access internet, router has got one public IP address. So router is actually taking note of everything, that which IP asks for what, and we always experience there is no miss data communication, and router always make sure that whoever asks for it, it also it always goes to him. So there is no confusion in it. So in order to avoid this, that the router is only connected with one IP address to the internet, whereas inside our home, we are connected with so many other IP addresses. The system, the protocol that is being used is network address translation, NAT. So if it is IP version 4, that we need network address translation, whereas if it is IP version 6, we don't need any NAT. However, NAT has nothing to do with our A level, so I'm not going to discuss it anymore, but you should know about it. Removes risk of private IP address collisions. When we have got less number of private IP addresses, I'm going to discuss this private and public IP addresses inside the home. Those addresses which we are using to get connected to our router are called IP addresses. Sometimes more than one devices have same IP address, so sometimes we have got collisions and conflicts. But it is all happening because the number of available IP version 4 addresses are less, and in version 6, since it has got a huge number of addresses with it, we don't expect any collision to occur. Uh, it IP version 6 has its built-in authentication, so it is more secure, allows for more efficient routing as well. All right, so there is one thing which is called zero compression. IP version 6 can be quite long, but there is, like over here, I have written one, but there is a way to shorten them using this zero compression thing. For example, this address can be written as let's take another address, for example, and discuss. There is, let's say, for example, 900B 3E4A E41 0000000. Then we have AFF7, and then we have DD44, and then lastly we have F1FF. So this can be, because of this zero compression, can be written as 900B 3E4A AE41 dot 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 AFF7 DD44, and then F1FF. Now what happens with the section, this section 00000000, this is replaced by colon colon over here, double colon. The zero compression can only be applied once to IP version 6 addresses. Otherwise, it would be impossible to tell how many zeros were replaced on each occasion. where it was applied, because so we can only apply it once. So let's say if we have got another pair of 00, we cannot we will be troubled actually. So uh, the zero compression can only be applied once to an IP version 6 addresses. Otherwise, it would be impossible to tell how many zeros were replaced on each occasion where it was applied. For example, so just understand that if we have got multiple pairs of such 0000 and 0000, we can only use it once. If it is, let's say, available over here as well, so we will not be doing it. We will only be doing it once. All right. Uh, there are other things as well that reduces IP version 6 um, length, address length. So let's discuss about private IP addresses and public IP addresses. All right, so first, private IP address. Private IP addresses are reserved for internal use. Internal use as in our home or at office. They are not for internet. Uh, for internal use behind our router, like the one that is placed by PTCL at our home, or um, in offices. These addresses are used, these class addresses are used for private IP addresses. Let's see. Class A range is from 10.0.0.0 to 255.255.255 after 0, sorry. And the range will become up to 16 million, because this part here has got 3 bytes. 3 byte means 2 power 32 bit, sorry, 24 bits, and that is actually 16 million addresses. In class B, we have from 172.16.0.0 to 172.31.255.255. This gives us up to 1 million. And then we have class C that we mostly use, that is from 192.168. That is what we use at our home mostly, or allocated by a router to our devices. If you happen to check your IP addresses, then you will find that mostly you have got these IP addresses. And since you can see that only variable part that we have over here is this, so that makes it 2 bytes, 2 bytes ranges. That means 2 to power 16, and that is up to 65,500, and let's say round it off, 65,600 possible addresses. So private IP addresses, which are internal values only, means it is only used inside homes and offices, not over the internet or shops. Allow for an entirely separate set of addresses within the network, means these IP addresses are not used, whatever that you see over here, or public IP addresses which are internet. They allow access to the network without taking up in public IP address space. However, devices using these IP addresses cannot be reached by the internet user. So internet user actually reaches to the router, and from router makes it sure that outside user reaches to you. Public IP addresses. Public IP addresses are ones allocated by a user's ISP to identify the location of their device, like the router that you have. Devices using these IP addresses are accessible from anybody using the internet. They are open to all. Public IP addresses are used by DNS servers, domain name servers, and network routers. And then we have directly controlled computers like in IoT, or well, directly controlled computers. Here they are used. Now let's discuss this DNS thing. One thing before we go any further, private IP addresses are more secure as they are inside our home vicinity, and public IP addresses are having their issues with respect to security because they are open to public. So let's discuss DNS, domain name server, as we have seen it over here. Domain name services, sorry. Over there, I meant server. Over here, we are discussing service. What service these servers provide? Let's discuss. The domain name server, also known as domain name system, gives domain names for internet host and is a system for finding IP addresses of domain names. Domain names eliminate the need for a user to memorize IP address. Like I would have um, I would have only to remember the addresses of the website, like the one that I have, zakonweb.com, and whatever the associate IP, I don't have to learn about it. We humans are made to learn names and addresses more than the numbers of those addresses in binary or in denary. Uh, the DNS process involves converting a host name such as zakonweb.com to an IP address. The computer can understand it. All right, so computer only understands in numbers form. So we have to actually be uh, having this service available through our ISP, so that whatever the address that we type into our computer's browser should actually have the IP address related to it. All right, so often DNS servers contain a database of URLs, universal resources. With them, the matching IP addresses. So what actually happens that we have our computer, let's say this is my computer. So this computer tries, whenever I type an address of a website, let's say that website is placed over here on this computer. This is actually the website server. Now I need to reach out to this website server. This website server has an IP which I don't know. I only know that this website address is um, zakonweb.com. This is what I have um, actually an idea of. Otherwise, I need this to be known. So I will ask with this to a DNS server. If this DNS server would have idea that what's the IP address of this given web address, it will give it back to me. So this is first thing, and this would be the second thing. And then my computer, knowing the address, let's say 25.36.198.32. This is the address given by the DNS server. Taking this address, my computer will reach out to this web server directly. Sometimes what happens that this DNS would not have the IP related to the address put. So there are several other DNS servers, and these all DNS servers are, yes, this one is second, this one is first, are related to each other. They are all linked to each other. So if it does not have this, it will ask this, and this DNS server will give it back the IP, and that IP then in turn will be given to me. That is how the DNS system works. The user, let me formalize it. The user opens the browser and types in the URL. In this case, the URL is zakonweb.com, and the web browser asks the DNS server 1 for the IP address of the website. The DNS server 1, if it can't find it in its own database, um, then it requests DNS server 2 to let it know. DNS server 2 finds a URL and can map it to the given IP address. The IP address sent back to DNS server 1. In case if it has itself, then it finds it itself. This IP address is then sent back to my computer, and this IP address is then sent back afterwards. This sent back IP address, my computer will now sets up a communication with the website server, and required pages are now downloaded. So that is how it works. The last thing related to this topic is URL, Universal Resource um, Locator. So let's study that as well. So uniform universal resource locator, or uniform resource service, uniform resource services. They both are called same way. Uniform resource locator, uniform resource URL. Web browsers are software that allow user to access and display web pages on their screen. So they interpret HTML sent from the websites and display the results. Every website is made up in HTML, so they display the results after having that HTML code downloaded to local computers. Web browsers are uniform resource locators. Web browsers are uniform resource locator to access websites. These are represented by a set of 4 numbers, which are our IPs, but it is much easier to type this information into browser like this format. Let's say, as you would have already seen, let's say first is protocol like HTTP. Then we have got website address like www.zakonweb.com. Then path, let's say A level, and then file name like abc.jpg. Protocol is usually HTTP or HTTPS. If it is secure, website address is www, which is domain host, and then name of the website. This is domain name, and then domain type. In this case, it is .com. It might be .org, .pk, .uk, .net, .gov, and so on, so forth. Path. This path is the web page. If it is omitted, then it is the root directory of the website. Like we have got C:\root directory. So path is actually the website itself. File name is the file that we are accessing. So that is how the whole thing works. So if we like to access a resource over the internet, and that resource always have a website. So if we like to access that resource directly, then we have to use uniform resource locator. This domain name just makes you reach to the website. So let's see how it works and how do we actually use it. Let's say I have loaded my website, and this is the image that I had. I made a copy of its address. So see, this is the protocol, this is the domain name, this is extension, this is the path, and this is the file name. If I type it, we get it directly over here. That is how it works. So let's have this one is completed. IP address is 1.2.2. Let's have a look at past paper questions. So this question is from October, November 2015. This question says the table shows 4 statements about IP addresses. Tick to show which of these statements are true. So the IP address consists of any number of digits separated by dots. That's false. Each number in an IP address can range from 0 to 55. This is IP version 4, so this is true. IP addresses are used to ensure that messages and data reach their correct destination. That's true as well. Public IP addresses are considered to be more secure than private. That is false. Now, uh, consider the URL http://cie.org/computerscience.html. Give the meaning of the following parts of the URL. HTTP. HTTP enables browser to know what protocol is being used to access information in the domain cie.org.uk, uh, which is the domain name. So cie.org.uk is the domain name. And computerscience.html is actually the web page. Sometimes the URL contains the characters this percentage sign and 20, and then um, this question mark, uh, because these things are not allowed. um, Percentage sign 20, because not allowed in URL. Percentage 20 is encoded for a space 32 in denary. uh, and this question mark separates the URL from the parameters or variables. You will be able to understand it more uh, after the discussion of scripts. Anyways, an IP address has the following value, which is 11.64.255 .90. Write the above IP address in hexadecimal. Let me see. This one be 0B, then this is 40, then this is FF, and then this one is 5A. Explain the format of an IP address. It is composed of, as we discussed, composed of 4 integers, which can be accommodated in a byte from 0 to 255 each. And that's it, I think. We don't have to write more. Study the following sentence. Study the following sentence. When a user enters a URL into their web browser, the DNS service locates the required resource. Explain how a URL and DNSs are used to locate the resource. So, a URL is a uniform resource locator, as we discussed, reference address to a resource, which is a URL includes protocol and domain name. Browser software sends URL to DNS. DNS is domain name system, domain name service, or domain name server, whatever you call it. Then DNS receives the name, and DNS returns, if DNS does not have the IP address related to that name in its database, it asks another DNS server, and it gets it back. And once it gets it back, it provides us with the related IP address, and then taking that IP address, we reach out to the server, web server, where we need to access the website. Next question. This is about um, IP version 6 as well, I believe. Access to the World Wide Web content uses IP address. State is what IP stands for. IP stands for Internet Protocol. The following table shows 4 possible IP addresses. Indicate for each IP address whether it is valid or invalid. And then we have to give a reason. So this 3.22a.6aaBbb, it is in hexadecimal. It is invalid because this is more than 32 bits. One, a 6aa or this BBBB in hex is bigger than 255 or FF. Thirdly, 6AA and BBBB are using more than 8 bits. Uh, sort of. Number two, let's see. This one is in denary form. 2.0.255, it is valid because it is in the range from um, 0 to 255, and these are 4 pairs, so it is fine. And 6.0.257, because this 257 is beyond 255 limit, it is invalid. And then hexadecimal, in hexadecimal you can directly see that J is not part of hexadecimal. Hexadecimal ends at um, F. So describe two differences between public and private IP addresses. Public addresses are those addresses which internet uses to reach out to the devices, and whereas private addresses are used inside our homes. And public addresses are insecure if you compare it with private addresses, and so on and so forth. So these are the questions, past paper questions, and that's it for the topic. I hope it would have um, um, helped you, and now you know IP addresses and URL and DNS things better than before. And we also discussed few of the past paper questions. There are other past paper questions as well, and I believe that there was one with the relation to the IP version 6. Do go through that as well. All right, guys. Thank you very much. Bye.